everybody, welcome to this talk about functional programming with Vite. Today we're going to be looking at incorporating a functional programming language into your Vite-based applications. I am Lindsay Wardell. I am a software engineer at NoRedInk. NoRedInk is a language learning platform for middle and high school. It helps students learn English. And we are also very, very familiar with functional programming. We like to use Elm and Haskell at work. I am also a podcaster, currently working on the Human Side of Dev podcast, where we talk to engineers and other people in the dev ecosystem about who they are, not just about the code and technologies that they work with. So diving into this topic, what is functional programming? Functional programming is, at its core, building an application by composing functions together. Typically, this is going to involve three of these things in some combination. Typically, the same inputs to a given function are going to have the same outputs. If we pass 1 and 1 into a function that's supposed to add them together, it should always come out to 2. If you give a function an input, it should give you the same output no matter what. We're also looking to reduce side effects. So that includes same inputs, same outputs, but also modifying data based on things that are happening inside of the function. It could be as simple as sending off an API request, or could be something more complicated, like, oh, you clicked this button, now we're going to do these 5 other things. The third piece is also reducing mutation. So we don't want to be manipulating our variables in the middle of things. If you need to change that value, typically in functional programming, you're going to get an entirely new value back rather than updating the one that you already have. Functional programming is also typically organized around data structures and functions rather than following an object-oriented approach where you've got objects with their internal state and their methods and then connecting them all together. Your code is going to be organized around data structures, functions that are tied to those data structures, and then manipulating it between the two. So, since we're going to be looking at Elm, what is Elm? Elm is a functional programming language. So it's going to be applying these concepts that we were just talking about. The same inputs equal the same outputs, reducing side effects, reducing mutation. Elm is also a pure functional programming language, which means we only have pure functions. In Elm, you cannot have side effects inside of a function. If you want to make an API call, you have to explicitly do that in the runtime of your application as part of the update loop, which we'll get to later. You can't just have a handful of API calls in the middle of a function, which also means that the Elm package ecosystem is a lot more stable and secure because they just can't do anything. Another nice thing about Elm is that it compiles to JavaScript, which is extremely important since we're working inside of Vite. Any Elm code that you write can be compiled to JavaScript and then incorporated into any front end that you're using, whether it's fully an Elm application or if you're using Vue or React or something else, they can play together very nicely. Elm is also statically typed. There's been a lot of debate about TypeScript, JavaScript, dynamic type, static type. Elm is a strongly statically typed language, which means you're not going to be able to pass in something that's truthy. You're not going to be able to say if the array has a length, then hooray, this is exactly what we want. You need to actually check on that and make it into a Boolean if you're caring about Boolean values. Elm also only has immutable data. You cannot change the data inside of a variable in Elm. If you're wanting to update those values, you need to go in and actually return an entirely new object and store that at the top of your Elm application. We'll get to that in a minute. Elm also has extremely helpful error messages. Some of the benefits of being statically typed and having immutable data is the compiler itself always knows what state your application should be in because you told it. You wrote your code. You explained what you wanted. So it'll be able to help you and say, hey, something doesn't seem quite right here. Are you looking for this? Or I can't handle truthiness. You really need to use a Boolean here. And the nice thing is Elm is going to tell you in a nice way, not just throw an error that's indecipherable. Also, Elm does not have a concept of null or undefined. There are no runtime exceptions. These are not things that you need to worry about when you're writing an Elm application. So let's compare the JavaScript and Elm ecosystems real quick. In JavaScript, if you want to install a package, you're going to be using npm or yarn or pnpm. Or if you're not using Node, then you might be looking at something like Deno, where you're accessing the files directly or some other method. And in Elm, all of this stuff is just built in. If you want to install a package, you just run Elm install and you bring it in. If you want to build your application, you can just run Elm make and it builds the application. It gives you a JavaScript file. Obviously, there's more to it and you can add more stuff on top, but this is the basics. If you're wanting in JavaScript to build an application, typically you're going to need a framework. You can use vanilla JavaScript, but most people don't these days. So you might reach for something like Angular, Vue, React. And in Elm, this is all built in. Elm encourages something known as the Elm architecture. And the Elm architecture is its own framework, but that's part of the language. It's not something that you need to install as a third-party thing. In JavaScript, if you're wanting global state management, you're typically going to reach for a global state management tool for the framework of your choice. So Redux, NGRX, Pinya. Sometimes your framework will include something such as in Svelte or Solid. But in Elm, again, this is all built in. And so you don't even need to worry about installing a framework to get your global state management. Elm state management is the core of an Elm application. Your state is always going to be at the root of things. In JavaScript, if you want immutability, you might need a third-party library. There's some proposals about JavaScript immutable records, which are looking really cool. But in Elm, it's already there. It's already built in. This is not something we need to worry about in the Elm ecosystem. In JavaScript, if you need routing, you need to reach for React Router, Vue Router. If you're going for a single page application, these are tools that you're going to need. In Elm, again, it's built in. These are just API calls that we need to watch for and see when we're changing the page. And if we're changing the page to something within a certain parameter, then just load this instead. We don't need to do a full page reload. In JavaScript, if you're wanting types, you can reach for TypeScript or JSDoc, or just no types at all if that's your thing. But Elm has types built in, and you don't necessarily need to even write them. You can just write your code, and Elm will be able to infer, oh, you're trying to do this thing, but you can't. You don't have the right type here, and it's going to help you and guide you along the way, and it feels really good when it's able to do that. In JavaScript, if you're wanting to lint your code, you can reach for ESLint. But in Elm, that's not built in, but there is Elm Review, which allows you to do the same thing, and it's fully written in Elm, and you fully customize it in Elm, which is a wonderful experience. In JavaScript, if you're wanting to format your code, you might reach for something like Prettier, but again, in Elm, it's not built in this case, but there is Elm Format. And Elm Format uses the standard formatting guide that the Elm website suggests that you follow. And in JavaScript, if you want to test your code, you're going to reach for Jest or Mocha or Vtest. And in Elm, this one is also not built in, but there is Elm Test, which allows you to run your unit tests for Elm right from the command line. Now, looking at some of the happy, friendly error messages that Elm offers. This one is for incorrect argument types, and we can see here, we have tried to pass a string instead of a number, an integer in this case. And the compiler, this is a message from the compiler saying the first argument to from int is not what I expect. It's a type of string, but from int needs the first argument to be an int. Do you want to convert a string into an int? Use string.toInt. So it's able to determine these things and give you helpful guidance rather than just throw an error and say, I got the wrong type, or whatever other languages may do when they get really angry and upset at you. Another case is the invalid case. So if we have an if statement, and in one situation we want to return a string, and the other we want to return a number or an integer, this doesn't work. The third branch in this case is a number of type number, but all previous branches result in string. And it suggests exactly all branches in an if must produce the same type of values. This way, no matter which branch we take, the result is always a consistent shape. This is some of that strong static type analysis that's happening here. And then they give you a link to custom types to learn how to mix types together. And then they give a suggestion. Do you want to try using string.fromInt to convert it to a string? So Elm is being extremely helpful as you're writing your code here. Truthiness is another one that we talked about. This if condition does not evaluate to a Boolean value, true or false. And we are just checking string.length, which is something totally valid in JavaScript because string.length would return a value that is greater than 0, which is truthy. And so it's saying here, this length call produces an int, but I need this if condition to be a Boolean. Elm does not have truthiness. Do that conversion explicitly. So again, Elm is trying to help us and guide us as we're writing our code, which feels really good once you get into it. This is a code example of Elm. This is just a basic application to render a button or two buttons. One you can click on to increment a value and one you can click on to decrement a value. Let's walk through it step by step though. At the top is some of our declarations. We're looking at module main, which means this is the main.elm file inside of our source. And we are exposing everything inside of it in case you want to run tests or when this code is compiled, that way its executable is available in JavaScript. And then we have some imports. We're importing the browser because we're running an application inside of the browser. We need to say, give us those functions, because again, everything in Elm is explicit. We're not relying on anything side effect wise in Elm. We're also importing HTML and HTML.events, so we have access to our DOM elements as well as the events that we're looking for, in this case on click. We then have an init, which just is 0. That is our default value for our number that we're wanting to click on. We then have two values here. So type message, that is a custom type in Elm. This would be seen in TypeScript as something like a union. And in this case, we're just saying increment and decrement. And then we have an update function. We are declaring the type of this function, which is update and then the colon, as message model model, which means we are returning a model, but we are expecting both a message and the original model. This is how Elm works, because we're not updating the values themselves. We're not manipulating or mutating anything. We need the old model so that we know what the new model is supposed to be like. If you've used React in the past, this looks a lot like a reduce. And then we declare update message model. So we have the update function itself and the two variables, message and model. And then we do a case statement, case message of increment model +1. And if we do a decrement, we return model -1. So now let's look at our view. This is the actual HTML that is going to be rendered to the page. View accepts a model. Div takes two arguments. They're both arrays. One is the attributes, and the other is the inner HTML, the content. So the div doesn't take any attributes, but does have some content. Both buttons take an attribute of onClick, and then we give it what message we want the onClick to return, either decrement or increment. And then we pass in some content, in this case, just text of minus or plus. And then there is an internal div that says text. And then we have a function call of string.fromInt to turn our model, which is a number, into a string, because you cannot render a number in Elm. It must be text. And then at the bottom, we actually create our application. So main calls browser.sandbox. That is a function that creates an Elm application that does not communicate with JavaScript. And then we pass init equals init. So we're passing in our 0 as the initial value. Update equals update. And view equals view, which is the HTML that we were just looking at. So if you're wanting to incorporate Elm inside of your Vite application, this is the plugin that you're going to want to reach for. Vite plugin Elm. This is just a standard Vite plugin. You import it into your Vite config and you put it inside of your plugins array. And then you're able to import Elm applications, just like the example here. Import Elm from myapplication.elm. If you're not wanting to incorporate Elm into your own application, there are two different frameworks I would recommend that both use Vite in the back to make Elm incorporate with JavaScript. First that I would point out is Elm Pages. Elm Pages is a lot like Remix or Nuxt, where all of your server-side rendering needs are handled. You can pull your data from whatever source you need, and it's just there, and you just get to work with it. So if you're wanting Elm on the back end, accessing a database or a CMS, what have you, this would be the full stack solution that I would look at for Elm. Elm Land is really good for single page applications, but it also provides you with file-based routing. Both of these are using Vite for the JavaScript and CSS compilation steps, and I highly recommend taking a look at both of those. If you're wanting to play a little bit more and build up your own thing, I maintain Vite Elm template. Vite Elm template is in the awesome Vite repository as well, and it's purely just what we were looking at today with an increment and decrement buttons and a couple examples of tests and how to use Elm review and Elm format in your own code base. Highly recommend checking that out as well if you want to see what it's like under the hood. There is so much more in the Elm ecosystem that I want to talk about, but there's just not enough time in the day. I hope you enjoyed this talk. If you would like to follow up with me, I am on all the social media platforms that I can find as Lindsay K. Wardell. I'm also on lindsaykwardell.com. And if you're interested in working with Elm or functional programming, highly recommend checking out my company's jobs board at NoRedInk.com/jobs. Hope this talk was informative. Enjoy the rest of the conference.